Let us have a look at this bow tie code now. And here I have just copied the code from the module 5 document, the first part down here to build the bow tie index. We run bow tie build, right, from the container. And then after that, there is some additional code for mapping the reads. I have also put into the same, but in the same shell script. And I've saved it here under the name bowtie2.sh under my module 5 folder. First of all, let me just comment out this last part now, because I only want to run the first part where we build the index. So how do you comment out? You highlight the code like this, and you go to the code in RStudio, comment or uncomment. So now this is sort of ignored, right? This part of the script. And this is something we do quite frequently. Comment in and comment out parts of our scripts, either R scripts or shell scripts. Because it's, in case there are some part of it we don't want to execute. But we don't want to delete it because we may need it later, right? And in this case we do. So remember to save the file then, once you made a change. Before I run now, please make sure you, when you use Apptainer container, make sure this works on in your sort of world, in your folder. Do you have a module 5 folder? Do you have the container in the module 5 folder under your home, like I have, or perhaps you have it somewhere else? Then you have to change this code. Is the name of the container file exactly this? You should always check that, right? Here I have it. It's exactly this file name, right? But this may not be the same in, I mean, my container file may be different from yours. So you must make sure this code is the same as, has the same name as your container file, not mine. Okay, so let's sbatch this. We go out into the terminal and we move to this module 5 folder. I can even list the content here just to see this is where I am now. Yes, this is the file. So let me sbatch bowtie2.sh like this. And if I try to list the queue now, I'm probably, too slow because this this is really fast. So it's already finished. Now the question is, did it finish properly or was there an error? When it finishes this quickly, I always suspect an error, right? Because with errors, it typically crashes almost immediately. So let me now go back to RStudio, refresh the window to get up the log file here. Because we created a log file, right? Here. So this is the log file. Let me click it open. It's always a text file, this. And have a look down here. It outputs a lot of things to the log file, this software. So we have to really scroll far down. And typically scroll down to the end and look for error messages. I can't see any error messages here. So this looks promising. And it actually says it took 3 seconds to execute. So probably this worked fine and no errors. So what about the output then? There is no output here. Well, not so strange, because we specified here that we made a variable called outdir that we used again here to make this index, and that's actually where we output things in index. So index is now outdir / bowtie, and outdir is again this one, right? So actually you should now copy this here and go to the terminal window and list the content of this folder. And you don't really have to move there. You can just list the content like this. And here we can see that this folder, first of all, it exists and it has been filled with actually 6 files, all starting with the same prefix. And that's exactly what we specified here, right? This text here is now used as a start of all the 6 file names. But they have different extensions, and this is how it should look like. When you make a bow tie index, it always results in 6 files with these particular names, or these extensions, you could say. So this looks promising. Let's now go back and include the rest of the code. So let me just highlight this again, and then I take away the comments again. So now it's included, and then I have to remember to save my file again. And let's rerun the code. First of all, what is the last part here? Well, here we say which read files we want to use for read mapping. The output should again end up in this folder, you can see, and now it's called Illumina _genome.sam. And here is the actual command line. Continues here. Remember that when you want to break a command line over several lines, you always have to end the first lines with this backslash and with nothing behind it, right? There should be no space or comments or anything after this one. So it continues here, and there are some options here. You can read about them. Threads. The insert sizes, that is minimum and maximum. Yeah, this is not really required, but it indicates to bow tie approximately how big spacing is between the forward and reverse reads in a read pair. Yeah. And then, of course, the index that we created up here, or has at least created before sometime, this here, and then the two R1, R2 files, the input files, and finally -s to indicate SAM format output to this file here. Yeah. Now let's go back and sbatch again. We can just use the up arrow to an up arrow again, and now we can see it's running, and if I type it again, it's still running because now it takes longer time. Let's list the content of that folder again. I also use the up arrow to list that again. And now you can see, first of all, the index has been recreated, but that exactly the same files. But you can see the time is slightly different from before. So it is a new version, but it's exactly the same, of course. And now you can see this Illumina genome.sam file has been created, but it's still empty. Let's list it again now, a few seconds later, and it's no longer empty. It starts to fill up. And if I add the -h option to get human readable format, we get the sizes in megabytes here, 522 megabytes. This file is now growing as long as bow tie is running, because bow tie is now taking all the reads, map them one by one, and then fill into this file the results. So if I list again, you can see it's still growing. 732 megabytes now. If I list the, yeah, it's been running for 1.5 minutes soon. And this file is now almost 900 megabytes. And there it's done. So it ended here, 893 megabytes, this SAM file. Quite a big file. We will have a look at this later, what next to do to this output. But this is actually the output from bow tie, the SAM file. Let's go back and have a look at the log file now. If I refresh here and look at the latest log file, click it open. Yeah, the first part will be exactly as we saw before. So I have to go all the way down. And this is the part that is added by the bow tie read mapping. So we can see that of the almost 600,000 reads, 100% of them are paired. Yeah, we knew that. 92% of them map concordantly, align concordantly. And what does that mean? It means that the forward and reverse read in a pair, they map to the genome in approximately within the distance that we expect, given the insert sizes. We see that some actually align more than once. And that's interesting because it means some parts of the genome reads map equally well to different places or more. And that is typical of a repeated region, right? We also see that some reads map discordantly, but they do map. And this means the forward and reverse read map, both of them, but not in the proper order or in the proper distance according to this fragment size, this insert size. But that doesn't really matter. So what we are really interested in at the end of the day is this: the overall alignment rate. How many reads mapped of the total bunch? And close to 99% mapped here, and that is really, really good. You cannot expect 100% of the reads to map, right? Because there are sequencing errors in some reads and enough sequencing errors to make them not match anywhere. But almost 99% is really good. If this percentage here is very low, you really have to ask yourself, did I use the correct reference file? Perhaps I used the wrong one, right? And then, of course, nothing matches anymore. Or did you use the wrong read files? That's the first thing I would look for. Did I do something wrong, right? Did I use some wrong files? If that's not the case, then of course the reference, if this number is super low, the reference is worthless as a reference, right? Because if only a small percentage matches here, it's not really interesting at all. It must be at least 80%, I would say, or something like that, 75-80% before it can be used for anything. But in this case, it was close to 100.